Ever wonder how AI learns to recognize faces? Like, it's not like we just open a book and show it, right?
Right, right. These deep learning algorithms, the ones used in, say, video surveillance, need tons of data, mountains of data
Yeah.
to really get smart.
And not just like any old pictures. We're talking about images that show all those weird angles and lighting and expressions, the stuff you actually see in real life. This patent application we're looking at today, well, it's tackling that. It's called, get this, a method for augmenting a plurality of face images. Bit of a mouthful.
There is.
But the idea behind it, it's actually pretty cool.
Yeah, when you think about those picture-perfect photos you find in a database compared to what a security camera actually gets, it's totally different.
Exactly. And that's where this patent starts. It's like, hey, those data sets, they just don't cut it.
Yeah.
We need to figure out how to make way more realistic images to train these AIs.
And how they do it, that's where it gets interesting. So they've got this whole process, multiple steps, and it kicks off by grabbing face images from two main sources. First, live camera feeds.
Ah, makes sense. Straight to the source.
Exactly, like
Yeah.
think banks, jewelry stores, places with tons of security cameras.
Right, places you'd want facial recognition.
Yep, exactly. But then it gets, well, a little more interesting. They're pulling images from the internet, too.
The internet, how does that even work?
So they're using keywords, right? Like
Yeah.
man, woman, face, even man with glasses,
Casting a wide net.
trying to get as much of that real-world variety as they can.
Interesting. So to really see how they handle all that, we got to look at this figure one in the patent. It's like their system's blueprint, 5 different databases, all these modules with names like data augmentation, GAN generation, fuzzy logic selection. It's a lot.
It can feel overwhelming, that's for sure. But those modules, each one has a specific job. Got to transform those raw images into something an AI can use for deep learning. It's the whole process.
Right. So let's break it down then, starting with those data augmentation modules, numbers 106 and 107. What's going on there?
Okay, so imagine you've got one photo, and you make, I don't know, dozens of tiny changes to it. You flip it, rotate it, tweak the brightness, you name it. That's what these modules are doing, taking those faces they've got and multiplying them, making a much bigger, more diverse set of images.
So it's like they're giving the AI a crash course in like all the different ways a face can look.
Exactly. They're showing the AI all those little variations is helping it learn to recognize faces even when the conditions aren't perfect.
Clever. But this is where things get really wild, right? The GAN module. Number 109. Now we're bringing in the big guns.
Yeah, we are. GAN stands for Generative Adversarial Network. Big word, big deal in AI.
And figure 2, it breaks this GAN down into 3 main parts. You've got your encoder, decoder, and discriminator.
It's like this, see? That encoder takes an image, and it creates this, well, almost like a shorthand version of it.
Like those facial composite sketches artists use?
Yeah, kind of. Then you've got the decoder, and it takes that sketch, that shorthand, and tries to rebuild the face from it. But here's where it gets really cool during training. That decoder, it learns how to make completely new faces. Faces that weren't even in the original set of images.
Hold on, so the AI is becoming like a portrait artist.
You got it.
That's incredible.
It is. And the discriminator, it's like the art critic in all this. It's looking at these generated faces, comparing them to the real ones, constantly giving feedback. Is it good? Is it convincing?
So it's like this constant back and forth, this battle. The decoder's trying to fool the discriminator, and the discriminator's getting tougher and tougher.
Exactly. And because of that whole adversarial thing, they actually both get better. The decoder gets amazing at making realistic faces. And the discriminator, well, it gets really good at spotting fakes. It's like a competition to improve.
So we've got these AIs like going head to head, trying to outdo each other. But how does this GAN thing actually go from like a sketch to a face that could fool anyone?
Well, that's the cool part about deep learning. It's all about patterns.
Yeah.
And I've seen them on a huge, huge scale. That GAN we were talking about, it's trained on this massive set of real faces. And as it chews through all that data, it picks up on all those tiny things that make a face look real.
So it's looking at like the way a nose casts a shadow, even things like, I don't know, the little wrinkles around someone's eyes.
Exactly. All those super fine details that older algorithms, they just wouldn't catch. The more data you feed it, the better it gets at putting those details into those new faces it's making.
Okay, so now we've got this flood of new faces, all these AI-generated images. I'm guessing not all of them are going to be perfect, though, right?
Yeah, good point. Not all of them are winners. That's where that fuzzy logic thing comes in. It's like a quality check. Only the best, most realistic faces get through to the final set.
So, how does it decide which faces are good enough? There's like an AI beauty contest going on in there or something.
Not quite, but kind of. It's more of a sharpness test. They actually use a real equation, the Laplacian equation, to measure it.
An equation. Sounds complicated.
It is, but it basically just looks at how sharp the edges and details are in the image.
So a face is a little blurry, a little pixelated, it's out of there.
Exactly.
Yeah.
Only the crispest, most real-looking faces make it through, if they don't pass. Back to the drawing board for the GAN.
This is wild. It's like this whole AI factory pumping out faces, thousands of them. But this is all just to make a data set for another AI, right? The
Yeah.
one that actually does the facial recognition part.
Right, exactly. That's where it all comes together. All these faces, the originals and the GAN-made ones, they get fed to this deep learning module. This one uses something called convolutional neural networks, CNNs for short.
CNNs, they're like the rock stars of image recognition, right? I've heard of those.
You got it. They're designed to work kind of like our brains do, breaking down an image into all its little parts.
So instead of seeing a face as just like a whole thing, it's picking out the eyes, the nose, the mouth, all the pieces, and figuring out the patterns that make each one different.
You got it. And because it's learning from this huge, diverse set of faces,
Yeah.
that CNN, it gets crazy good at IDing people, even in tough situations, bad lighting, whatever.
So just to be clear, we're using AI to create more data, to train another AI, to be even better at recognizing faces. Talk about meta.
Yeah, it's a wild ride for sure. But it goes back to what we were talking about. Deep learning needs data, and I mean a lot of it, to do what it does best.
I get it. It's fascinating stuff, but I gotta admit, part of me is kind of, I don't know, uneasy about this. We're talking about giving AI the ability to create perfect images of people. What could possibly go wrong, right?
Yeah, that's the big question, isn't it?
Yeah.
Like with any powerful technology, there's always going to be that risk of, someone using it for the wrong reasons. But we're still early days with AI. This is just the beginning, figuring out what it can do.
Okay, so beyond all the, well, slightly scary stuff, what are some of the, good applications of this tech, besides just making facial recognition better?
Oh man, the possibilities, they're huge. Imagine making video games or movies, but you don't need actors. The AI just creates these photorealistic images for you.
Well,
Or what about creating avatars, but they look and move exactly like you? Virtual reality just got real.
now we're talking. It's like we're walking into one of those sci-fi movies.
It's definitely an exciting time to be working on this stuff, that's for sure. But, and I think this is important, the further we push this tech, the more we got to talk about what it means,
Mm.
ethically. What are the implications of all this?
We've invented these tools. They're incredibly powerful, and now it's on us to make sure we don't misuse them.
Exactly.
Yeah.
And that's a conversation everybody needs to be a part of.
Mm.
Not just scientists, but, politicians, regular people,
Yeah.
everyone.
Yeah. It's kind of, I don't know, a double-edged sword, right? This
Yeah.
technology, like on the one hand, you've got these amazing possibilities, could change entertainment completely, but then there's the potential for, well, deep fakes, really good ones.
That's it, isn't it? It's a tool.
Yeah.
And like any tool, it's not good or bad on its own. It's how we use it. But with AI, especially this stuff, making stuff up, generating things, the stakes are so much higher.
For sure. And it's not just about, some bad guy making fake videos to cause trouble. Even if everyone's trying to do the right thing, there's still bias. If the data you use to teach these AIs isn't, well, diverse enough, if it doesn't represent everyone, you could end up with algorithms that are just, I don't know, making the same mistakes we do, just on a bigger scale.
Absolutely. Bias is huge in AI. It's
Yeah.
something researchers are trying to fix. Yeah, definitely. One way is to be really, really careful about the data they use for training. Make sure it includes all sorts of faces, different ethnicities, genders, ages, everything.
So it's not just about the quantity, it's got to be the right kind of data.
Exactly. It's like, imagine trying to teach a kid about the world, but you only show them like one tiny part of it. Their understanding is going to be, I don't know, limited, right?
Huh?
It's the same with AI. Got to show it everything, the full picture, if we want it to be fair.
Makes sense. But even then, even with the best data, making AI that's totally unbiased, that's got to be tough, right? I mean, we made these things and we all have our own biases, We can't just switch that off.
You said it. Even when you're trying your hardest, getting rid of all bias, it's almost impossible. That's why it matters who's building this stuff. The teams working on AI, the engineers, the researchers, but also the people deciding how it gets used. The ethicists, everyone. It needs to be a mix of people from all walks of life.
So it's not just about the code, it's about the people writing it, the values they bring to the table.
100%. We need everyone involved to make sure this stuff is built right and used the right way. It's on all of us, really. We all have a part to play.
Man, This has been eye-opening. We've gone deep. The tech side, the GANs, the fuzzy logic, but also the bigger questions, like what does it even mean to have AI that can recognize faces, you know?
Definitely fascinating stuff. And hopefully for everyone listening, it's given them a better idea of not just how this tech works, but why it matters,
Yeah.
what it could mean for the future.
And hopefully got some gears turning up there too, because it's clear this AI thing, it's powerful. And with great power, well, you know the rest.
You said it. What AI is going to be like in the future, that story's being written right now. And we're all a part of it. We got to make
Okay.
it something we can be proud of.
Well said. And that's a wrap on another deep dive. Thanks for joining us, exploring the world of AI. And as always, keep those brains buzzing, keep asking questions, and keep on diving deep into all that cool knowledge out there.